Describe the geometrical transformation that maps the graph of y equals sine x onto the graph of y equals 2 sine x. So we're doubling the y values there, aren't we? And C, use a trigonometrical identity to solve the equation 2 sine x equals cos x. Between x is 0 to 2 pi, and solution should be given in radians to 3 significant figures. So here's what we've got then. So let's have a go. So part B. Well, when we double the sine to this, we're doubling. So it's a stretch in y direction, vertically basically, by a factor of 2. We're doubling the heights basically, aren't we? By a factor of 2. Now part C. Solve using the trig equation, this equation here. Dividing by, let's divide by cos. See what we get. And there we'll get cos, that will give 2 tan of x is equal to, cos divided by cos is 1. So that tells us then that tan x is equal to a half when we move the 2 from times down to divide. So tan is positive. Let's write our circle with cast. Tan is positive here and here. So draw our 2 lines, mark off alpha, the associated acute angle, and simply write tan alpha is equal to the value without any negative. So that tells us what alpha is then. Shift tan of 0.5. So shift tan of 0.5 equals 0.4636. 0.4636. So x is equal to, then we can read off the solutions. The first solution will be around to here, which is this value, and this would be 0.464 to 3 significant figures, and the other value would be this value around here, wouldn't it? Pi plus this value alpha. So let's add a pi plus pi. Let's see what we get. We get 3.6052. 3.6052. So this is equal to, this was to 3 significant figures. And then we can do this to 3 significant figures. It's 3.61. So I'll put that in straight away here. 3.61. And that's also now to 3 significant figures. So x equals 0.464 or 3.61, both to 3 significant figures.